All right. Hello, everyone. This is workshop number 2 as part of the Decreasing Frictions in DeFi Hackathon series. So, for those of you who might just be joining, this is an ongoing hackathon sponsored by ZeroX, Polygon, AWS, and Family. And this is an online hackathon where builders and developers such as yourself can showcase your innovations to solve real world financial frictions using ERC20 swaps. Project ideas could include wallets, payments, portfolio managers, investment strategies, or even in game currency exchange. If you need an idea, check out the blog post linked below titled Inspirations for Building with ZeroX Swap API. However, we are open and interested to hear what ideas you have that we haven't thought about yet. Prizes for this hackathon include $30,000 worth of awards, and the top 3 winners will be showcased on our marketing channels, helping propel your app to the next level. There are also ongoing workshops such as this one, and the schedule for those can be found in the description link below. And some important dates to keep in your book are that submissions are currently open, running from June 2nd to July 2nd. This means that you can submit your builds anytime in this period, and winners will be announced on July 10th. So check out the link in the description below or scan this QR code for more details. And last on my list before we dive into the workshop is the list of judging criteria for the hackathon. So make sure you implement the Swap API endpoint on Polygon mainnet or Mumbai, and that you're integrating ConnectKit. We're definitely seeing a lot of projects rolling in already, which is awesome. And so we look forward to more and making sure that all eligible applications include these required components. So with those logistics out of the way, let's dive into this workshop. So this workshop will be covered by Aaron Sempf, Principal Solutions Engineer at AWS. And he'll be covering how to build an end-to-end decentralized application using AWS basics. Note that while this is not a requirement for the hackathon, it is, though, a very important paradigm to be aware of as you take your hackathon from MVP state to a production-ready application. So with that, let's dive into Aaron's presentation.
Welcome to AWS Web3 development. This is Lab 3. For those of you who haven't been through Labs 1 and 2, in Lab 1, we took a look at setting up your wallet. We looked specifically at the Ethereum blockchain, creating contracts, and also different types of contracts. So looking at crypto, looking at tokens, looking at NFTs, and essentially what are decentralized oracles. In Lab 2, we started to develop a Web3 DApp, or a decentralized application, utilizing a React SPA, single page application, and the Infura API to connect to Ethereum Go Early test network. And we took a look at setting up your local development environment with either the Brownie framework for Python or the Truffle framework for JavaScript, and then developed our basic React decentralized application, which was a FundMe application with a Ethereum contract for holding crypto. And we could then send transactions to that contract, and the app would demonstrate a collection, or demonstrate the value of all of the donations to that contract. In today's lab, we will be continuing on from the decentralized application, so utilizing React single page application. For the benefit of those who haven't done Lab 2, I will point out at a high level how to develop the app from scratch. But I will have it already pre-developed on my demonstration, just pointing out how to go about developing from the beginning. But we're going to extend that further by bringing that application onto AWS, so hosting it as a static application, as we do with other static web applications. We'll be hosting it in an S3 bucket behind a CloudFront distribution. And then we're going to be separating the actual backend from the front end, so separating the communication with the blockchain from the actual front end itself to behind the API. And the API will talk to a AWS Lambda, which is what's doing the communication with the blockchain through an Amazon managed blockchain node. So we'll go through and we'll look at how to set everything up to do that. And then for the benefit of those of you wondering why we're separating the backend from the front end in this way, this leads to Lab 4, where we'll be looking at abstracted accounts so that we're no longer having to rely on the wallet at the front end. We can set authentication and allow us to do a lot more integration with the blockchain, as well as adding additional or traditional Web2 backend components, such as data enrichment, working with local databases for information we may not want to store on the blockchain, but we want to enrich for data that we're pulling off the blockchain. So stay tuned for that. That'll come in Lab 4. So we're going to start with setting up our Amazon managed blockchain. Then we'll set up our backend, and then we'll take a look at the application that we're developing in terms of the hosting and the actual React single page application. So to start with, it's simple to set up the Amazon managed blockchain. There are two main ways. One is through the CLI and one is through the console. I'm going to be doing it through the CLI. However, if you would like to follow along going through the console, click on the console tab and you can see the instructions that will take you through doing exactly what I'm doing in the CLI. And that's for the benefit of those who don't have the AWS CLI already set up and configured. If you've just new to AWS and you're utilizing the console and haven't set up a development environment, or even just set up the AWS CLI, this would be the same way to do that. And when you go into the console, you will be greeted by the Amazon Managed Blockchain console. Sorry, when you go to Amazon Managed Blockchain, helpful if the whole word is spelled. So when you go to Amazon Managed Blockchain, select there, you'll be greeted by the console opening page for AMB, or Amazon Managed Blockchain. We will be adding a node to a public network. So I'm going to go through and do that on the CLI to show you how we're doing it in the workshop. But I've done this previously, so I will also have an existing network. You won't have this existing network, but this is what you're about to create. So in the CLI, we want to use the manage blockchain command. We're going to connect to the Ethereum Go Early network. So that's a test network. We're going to be setting this application up in the US East 1 region. And our node configuration, so the actual server that the node will run on, is going to be a BC-T3 large. That's our EC2 instances running inside a US East 1A availability zone. You can change any of this if you like. It's essentially just where it's going to sit in your VPC and the size of the instance that we're going to be running. So when you fire that off, if all is successful, you should be greeted with a response of the node ID. So that's important. Go and grab the node ID, copy paste that out to a text pad or a notepad. You will be using this in subsequent queries to understand the status of the node and for integration. So the next command that we're going to look at, before I get to that, I can show you in the console. You can see I've got actually two others creating, because this is not the first time that I've attempted to record this workshop. So two previous instances still setting up. It's going to take about 30 minutes to actually set up a node instance. So I'm going to be using the node that I'd set up previously. When you click on that node, you're going to get all the status information, which you can see here in text, which we'll do through the CLI. Big pun for those of you following along in the CLI. If you do, one of my previous ones is now available as well. If you do this command while it's still creating, that's okay. It's going to go and tell you that the status is still creating, as you can see here highlighted in the workshop. I'm going to, first of all, jump to the next page, because it's the same command. I'm going to do out of that. I'm going to do a manage blockchain get node. So now I want to look for the node that I've either just created or the one in this instance that already exists, to get the status. But from there, so if we click enter, we should get a response. I can see that the status is now available. And so you'll have status available once that node is created. the important thing that we want here is the endpoint and the WebSocket endpoint. So if you go and select those two, so endpoint and WebSocket endpoint, copy those and go and save those into your textpad. We're going to use those later for integration. These are the bits that we need to communicate from the Lambda to the actual node instance. And in terms of communicating with the node, the way that we're going to do this is there's a couple of different methods. The way that we've chosen to do it in this way is using SIG-v4 signing process. So we're going to go ahead and create a Lambda which captures the request and does a SIG-v4 signature to allow the communication between the Lambda and the A and B node. But before we do that, we actually need to set up the actual authentication. So we need the AWS IAM user created that we'll be using to handle the communication between the Lambda and the node. The way that we do that, again, if you go through the console, you can do this through IAM. If we're doing it through the CLI, all we need to do is select AWS IAM create user, and in this case, we're setting ETH HTTP client as the username. If you go ahead and do that, you should see the response of it's created. We have a username, we have a user ID that we can use, and the resource locator, so the ARN for that username. Now, the next thing that we want to do is we want to go ahead and generate a credential or credentials for that user that we can add to the Lambda to execute as this user. So we will run this command create access key for that username that we just created. I'm not going to do that because I don't want to show you the access key and secret key. The one that's in this workshop doesn't exist. That's a false one. But when you go ahead and execute this command in your CLI, when you hit enter and execute, go ahead and copy the access ID and the secret key to your text pad, and we're going to use those for integration between the Lambda and the node. All right, so let's jump into the backend. If you recall the diagram that I showed at the very beginning, we had at the very bottom let's go and look at it. We had the Lambda, top. We had the Lambda talking to the managed blockchain. So we've created the managed blockchain node, or it's still creating. We're now going to create the Lambda and then the API that will allow the application to talk to the Lambda and the Lambda to talk to the node. So the first thing that we want to do is we'll create a new folder and jump into that folder, and we'll just run an npm init. So the npm init, if you're doing that in CLI, these are the CLI commands that you need. The npm init will create just the package.json, and we can call this whatever we want. I've called it Web3 Lambda. The most important parts are the name and the main. So we want index.js as our main, and the rest you can use as default. This basically just sets up for us a basic project folder. You wouldn't have anything in it at this stage because all we've done is npm init, except for the package.json. Then what we want to do is we want to start installing some dependencies. The xhr2 dependency is what we'll use for our SIG-v4 signing. And for those of you who have done the Lab 2, you'll recall that we used the Web3 JavaScript library. We're going to be using that as well in the Lambda. So the Lambda will be using the Web3 library to make requests to our Amazon Managed Blockchain node. So those are the two dependencies that we need. Go ahead and run npm install Web3 and xhr2, and that will create the node packages folder and add dependencies to your packages, to the package.json. Then what we want to do, instead of showing you in the workshop, I will pull it up. That's the wrong one. I'll pull it up here so you can see. The code that you have in the workshop. So this, if you copy paste this, this is our SIG-v4 signed HTTP provider. So what this will do we'll quickly step through this, is now we're importing our SDK so that we can actually use the AWS SDK to talk with the AMB, so our local what do you call it? Our local node. Um, we're importing URL from node. As what we're going to do is we're going to be capturing a request, and we want to create a correctly formed URL, and we're using the HTTP provider library from the Web3 provider's HTTP library. So this is an extension of the Web3 provider's HTTP. Now, again, for those of you who went through Lab 2, you'll recall where we set up a provider using the default provider, which was our local wallet, to then make a request to Ethereum blockchain. In this instance, we're actually going to create our own provider, and that is the signed. Oh, it's a Web3 HTTP provider, and then we're going to sign that request with an XHR2 signature, and a SIG-v4 signature with a XHR2 request. So the rest of this function essentially is setting up our send function. So on top of the signed HTTP provider, so we're creating our new HTTP provider as a signed HTTP provider. So we're extending the HTTP provider with our own send function, which will create our signed SIG-v4 connection to our Amazon managed blockchain. So this is important. The service name is important. So when we do actually send the request, it will actually be looking for managed blockchain. So if you change this to anything different, it will fail the request. We're setting our request header, and then obviously we're looking for the on ready state change function. I won't go too much deeper than that. I'll allow you to go do the Q&A for after running through, just so we can save some time. And then essentially we're just sending our request as our SIG-v4 authorized request, adding obviously also our required headers for the XHR request. Okay, so let's quickly jump back to the workshop to show you the next part that we're doing. So that's essentially the HTTP provider, or the handler, the request handler that we will need to use in the Lambda that we want to use to communicate with the Amazon managed blockchain. So that's the easy part. You don't really need to do anything here or change anything here. You can copy paste that into your project. I will show you the whole project structure again, instead of just looking here. So I've got inside my, you've done init and you've done install of your packages. It's gone and installed the required node packages. Let's go and have a look here. So we've got AWS SDK as a dependency. Sorry, I didn't tell you to do that. That'll be next for the actual, oh no, we did use it. Sorry, my apologies. You'll also need to do AWS SDK install as a dependency, and then you also did Web3 and XHR2. So those dependencies are there in your node packages. The signed HTTP provider is the one that we were just looking at. So that's not the index.js. That's not the index of our Lambda. That will be used in our Lambda. So that's what we're going to do next. I will quickly jump back, as I said, to our workshop. So here you can again copy paste the entire Lambda that you need. This is where we will create in the index.js file. So in our index.js file, we create this this Lambda. I will skip over everything there in the workshop and just step through it in the code so you have an idea of what we're doing here. This is the one where we're actually going to import Web3. So we're using Web3 now to communicate with our AMB endpoint, but we're actually pulling the endpoint from a environmental variable. So when we go through and we set up the Lambda, we'll have to set environmental variables for the HTTP endpoint that we copy pasted from our AMB creation. The most important parts. All right, so we're doing a access control allow origin of all at this stage. inside the Lambda as a option for talking to the A and B node. We're using the sign provider. So when we set up the Web3 library, as we did in Lab 2 for creating our DApp, we set a provider for Web3. So the Web3 library knows what to use when sending the request. Now we're actually using our signed HTTP provider. So when we send the request to the node, it's doing our SIG-v4 signing. And then the functions, the rest is basically just creating some simple functions. Let's hide this for now, as this is not required for lab 3. So the simple functions that we want for this lab are essentially getting the balance, getting the network type, getting the owner, so who owns the contract or who owns the wallet. So all we hand in is an address, and we go and do that query on the Ethereum network. And that's it. So the rest of the actual Lambda itself is creating an extensible what would you call it? A hash dictionary. So we're using a hash dictionary instead of using in your handler. If you're familiar with creating lambdas, you might be familiar with, when every lambda has its export.handler, and it hands in the event object, and then you might be familiar with, looking at the event object and doing some if statements and then adding a switch. So doing a case, if it's this, or for the switch, the case of if it's a certain option, then do this or this or this or this. The way that we're doing it here by using a hash dictionary allows us to say, well, if it's just a options, then or a get, then we're going to just send back a healthy yes, it's there, it's available. This is a health check. Otherwise, what we want to do is we want to use our hash dictionary and use the actual hash dictionary to pull the actual path that we're actually communicating on. So this is a way of extending the same way that we did with the Web3 library in Lab 2, but now we can control the request that we want to make via the path that we use on the API, and that'll become a more apparent when we actually set up the API how we do that. But that way we can actually we can use the path for the libraries that we're pulling from the Web3 library. Sorry, the functions that we're pulling from the Web3 library. So we don't have to go and create all this extra code just to be able to pull some simple requests from the Web3 library. And then all we're doing is we're extending those, so the path contains the actual functions that we want to execute. So that's the ones that we created here. So the get network type is just calling the Web3 ETH network get network type. And so we're just returning the function that we want to query from the library. And that's essentially all the broker is doing there, all the hash dictionary is doing there, is allowing us to hand in the path parameters, and then any methods or parameters that we want to hand to the broker that we need, to the hash dictionary that we need for the query. And that's it. It's really quite simple. It's basically just setting up our functions, setting up our broker for those functions with a hash dictionary, and then saying, based on the request that comes in from the API, hand it off to the function that you want to execute, and then hand the response back to the user. So that's it in terms of creating the backend for the logic. Let's go back to our so essentially, let's jump over to our Lambda environment. If you haven't used the console before, typing in, you don't even need to type in AWS, typing in Lambda, go to the Lambda console. You will be uploading the Lambda that we just created. So the first thing that you'll need to do is, from our code, you want to, wrong code, you'll want to zip the entire container, including the node modules. So this entire folder that you've created, you want to zip that up. So inside the zip will be the index.js and the signed HTTP provider. Those are the two important ones. The package, not so much. That's for management. And the node modules, yes, you want that there because the dependencies that you've installed will use modules from the node modules folder. So once you've packaged that up, let's go back to our create a Lambda. By going to create Lambda, we want to author from scratch, give it a function name. In this case, we've called it my DApp backend. It's a Node.js environment. The latest is fine. On x82 architecture is fine. That's it, basically all we need to do. We're going to go and create that function. And then once you've created that function, you will be able to select upload source. I have already created this previously, so I'm not going to click upload source, but you can go ahead and do that, upload source, and that will add the files that you've created as your Lambda. Now, once you've done that, you'll also see, because I clicked upload from zip file, you can't actually view the source when it's uploaded as a zip file. So there's other reasons why we use SAM or serverless framework or even CDK for deploying into the backend so that we can manage our Lambda source in a much easier way and be able to see it and modify it and then quickly deploy it back instead of having to upload a file every time. But for now, we're just looking at the simple connection of everything. So we want to connect the AMB node. So connecting the Lambda to the AMB node is as simple as what I said before. We've already set up environmental variables. So we've already set up our Lambda to talk to. So it's asking for the HTTP endpoint and the secret key and the access key, all of these that you need that you've selected from creating your user and the region that we're in. So go ahead and create those environmental variables, and they'll be used directly by the Lambda as we saw previously, where we're asking for the AMB HTTP endpoint and in our signed HTTP provider, understanding the access key and the ID. All right. So once you have your environmental variables set up, that's it in terms of setting up the execution of the Lambda, because we have the user that we're using to execute against the AMB. We know the endpoint for our AMB. Then what we want to do is we actually want to set up an API gateway as a proxy so that we can just query an API endpoint from our application instead of having to make multiple requests to different places or integrating directly with the AMB node. So go ahead and click Add Trigger. And adding trigger, we want to select API Gateway as our trigger type. We're going to create a new API. You can also add to an existing API, and we just want to add it to create a REST API. And then go ahead and add. So I've already done that. When I click on this guy here, it'll show me that I've got resources here. When you go ahead and do that, it will create the API for you. If you click on the API that's created for you, it'll open up the API Gateway console, and you'll be able to, depending on what you've called it, you'll be able to select the API resource or the root resource in this case. And we want to actually go and add a resource. So if we go to Actions and Create Resource, this resource that we want to create, we want it to be a proxy so that it's a REST API, which allows us to set the path variables as we've just discussed we need in the Lambda. But we want to be able to just say, take the path and use that and hand it to the same Lambda. So we go and create a proxy resource. Calling it proxy, that's fine. Leave the resource path as is. And we want to enable CORS at this stage so that anyone can basically make a request from any application to our API. If you want to lock this down, and we'll be looking at this further in the next lab, but if you want to lock this down, we can remove CORS and just lock it down to the actual domain that we're sitting on. But in this case, we won't have a domain at this stage, and we're just allowing any request. It's essentially a decentralized application, so it's open to public requests to this API, which is only going to allow you to execute the Lambda onto the AMB. Go ahead and create the resource, and that will create you your proxy. The next thing that we want to do is link that proxy to the Lambda that we just created. So you go to the any request, so that's any verb, so post, get, put, whatever. We want any verb. We want to select a Lambda function proxy. We want to select the region that we created it in, the name of the Lambda, and hit save. And that will essentially, as you can see on this side of the screen over here, that will set up that you've got any request verb coming through, going directly to a Lambda proxy, which is the Lambda that we just set up. So if I click on that, you'll see that that takes us back to the Lambda that we just uploaded. All right. Now, the second last thing that we need to do is look at the hosting. So the hosting is as simple as creating an S3 bucket. So if we go into S3, we go and create a bucket and give your bucket a name. In this case, we've called it Web3 AMB front end. Select the region, best to select the region where your API is, just so that they're in the same place. Not a big issue. We can have different buckets in different regions and the like, but better to keep them together at this stage. That being said, when we do set up a distribution, we can set up to distribute out to every region, so it's cached closest to every where the user's making the request. So once we've created our bucket, that's all we need to do. It's as simple as creating the bucket with the default settings. So we're blocking all public access. We don't want public access to the bucket. The way that we provide that public access is via creating our Amazon CloudFront distribution. So go ahead and create a bucket. Then once you've created that bucket, we can go over to CloudFront. And as you can see, I have multiple CloudFronts because I've done this before. If you have none, that's fine. We want to go and click on Create Distribution. Under our distribution, we can select the Amazon S3 bucket that we just created. So that's the Web3 AMB front end bucket that we created. Based on whatever the name that you created. Obviously, everyone can't do Web3 AMB front end. I should have said that before. Bucket names are unique globally, so you can't have the same bucket twice. Select the bucket that you want to use. We want to, this has changed slightly. Origin path, that's fine. You can leave that. Give it a name for your distribution. Generally, the same as the bucket is fine. Add header, enable origin shield. Default cache behavior. I think you can leave everything as default. Okay, so we want to go over to legacy cache settings. No, we want legacy access settings. Things have changed in the few days since I did this last. Looks like all defaults is fine. Okay. I think that's fine. So if we create that distribution, yeah, okay, so a cache policy is required. Oh, and I haven't named, obviously, so go ahead and name those origin shield, cache policy. Yeah, just use the origin request. So we do want an origin request policy. That's recommended. So that's essentially what I was doing here with the legacy access identities. So it will create an origin request policy. So go ahead and click on, if you don't already have one, you'll want to do a create origin request policy. Give it its simple name, doesn't matter about a description. Headers should be all view headers, and we want all at this stage, and create that. I'm going to ignore the create because I'm not actually going to create this. I've created it already. I don't want to create another one. So that will create your distribution and link it to your bucket. So Web3 bucket. Let's go ahead and open the one that I created before. So you can see I have a Web3 bucket with the origin access policy pointing to my bucket. So that means that only the CloudFront distribution will be allowed to talk to the S3 bucket or access files in the S3 bucket. I can't expand that out, but okay, so we have our origin access policy. I've used all the default settings. So you should be fine in terms of setting up a default origin access policy. Default cloud distribution. We can look at in the next lab, locking that down if you want specific regions or extending it out to other regions. And now, once we have our distribution, we have our okay, so that we don't need to test that. Basically, all the last instructions here is doing is showing that if you drop an image in the bucket, we can test that the image is accessed via our CloudFront distribution domain name. So that's this guy here. If you copy paste this is where you'll be accessing your application once everything is up and running. So I'll drop that there. You can see that's running there. I also have my local running here. There you go, it's starting to update. So we'll come back to that in a sec. But there's your CloudFront distribution. So you know that the contents of the S3 bucket are being served out. Finally, the last bit is setting up the actual application itself. So this is where, for those of you who went through Lab 2, this is similar in setting up the same application. We're going to start with creating a React app. So we'll just use the create React app node package execution, which will set up all of the scaffold for us. And if you run npm start, it'll show you the base React app. The dependencies that we need or that we'll be using for this application are Bootstrap and React Bootstrap, just so that we don't have to do our own CSS and styling. We're going to be using AWS Amplify library only. We're not using Amplify in the backend because we're using the library to connect to our API. That's basically all we need to use the Amplify library for. Just makes it a little bit easier. And we're still going to use the Web3 library, but we're only doing that to connect to our local wallet. We don't need to make requests through the Web3 library locally because we're going to handle all of those requests through the API. So by default, you'll have your create React spa, and you can start copying. So the rest of the tutorial will show you how to step-by-step copy through the code. I'm going to jump into the code so we can see exactly what I'm talking about. Make it a bit easier for you. So this is the code that the very last bit that we looked at on the workshop was showing you. So this is the structure that we're going to add our application into. The two important parts that we're going to be building are the fund card and the user card. So the user card is our wallet, so demonstrating what's in our wallet or looking at who we are and what's our current value, and the fund card. So now we're just looking at the contract. So we're going to go and find that contract. For those of you who didn't follow Lab 2, you will be able to grab the contract. I believe. full app. Okay, so I didn't provide the contract as a download on this page. So if you go back to Lab 1 and go into actually Lab 2 and grab the contract, fund project for owner. Here's the solidity for the contract. This is what you would need to go through and deploy onto the AMB. So if you haven't already done that, I recommend going through at least Lab 1 and the contract that you create, go and create this contract and use it to deploy onto the Go Early network, or run through Lab 2 and understand setting up your development environment and deploying that contract out. So that's the contract you'll be using for interaction with the DApp onto the AMB or onto the Ethereum Go Early network. So that contract, we actually, once we generate that contract, we store that contract, or we store the interface for that contract as a JSON file. So this contains all the information about the contract that we deploy onto the Amazon managed blockchain or onto the Ethereum blockchain. So we will need this to grab from it its address and its interface. So the ABI is its interface. So what are the functions that we can call? What are the inputs and outputs? And the address. So where does it sit on the network? What's its address on the network? So that's what we use to hand in to our functions to then go and query, what's the network type. So that's how we pick up what's the network. And the balance of our not our contract, well, the contract balance and our wallet balance. So I will quickly just run through the rest of this. Okay, so I will step through in the code up to here. Okay, so what we're actually doing in our web application is, so we've got our app. We'll quickly step through the components that we want to create to display. The two things that are important that we need are, first of all, we need to communicate with the API that we've created. So we're creating a Web3 API JS. That Web3 API JS will do two things. It will pull from the config that we create. So using the Amplify library, we will pull the config. The config here is where we store our HTTP API, our API gateway REST endpoint. So go and grab your REST endpoint that you created and basically add it to this structure here. This is the structure we need for the Amplify config. We want an API with whatever endpoints. I'm calling it Web3, and that's the endpoint. That's all we need. We then import that config, and we use that config with the Amplify library so that now when we query any of the API calls, so when we do an API.post, we don't need to set the URL or anything like that. It's all configured for us through doing this. The next one is setting up our Web3 local. I'm using the Web3 library to set up just using the Web3.given provider. So the given provider will look for your local wallet. And then using the Web3 given provider, we can get the current provider selected address. So that's your current wallet address. So we've set up a function for getting the request user account. Then the rest of this Web3 API is basically just sending requests to the API. So we do a send request, we specify the path, the method, and any parameters that the function needs. And we're handing that off directly to the API gateway as a post with the method and the params as part of the body. And the path is we add to the actual post. So it will add or append the API URL with /path, whatever path we put in here. So that could be our /net/balance or contract/balance. Finally, we set up our individual functions that we want to call. So instead of having to break down each of the functions every time within our application, we just set some specific functions. So get network type, instead of having to write the eth/net and get network type function in our components, we just provide a very simple get network type, and we send the request for the path eth/net, the function get network type, and there are no parameters that we want to send to that method. So then we just send that as a post with no method. For getting a balance, it's a little bit different. We send the path eth as the path. We're calling the method get balance, and the parameters that we are sending are the actual address. So it will use the address as a parameter in the lambda that we created for getting the address, to go and query the network to go and get the address balance. And then finally is the so get wallet. Sorry, that's go and copy this. This is just using some failover request. If it doesn't get it through one method, it will use another method to go and get the local current provider. So that's your selected address. What I meant was finally the get contract owner. So now we're actually looking at the get owner method on the eth/contract, and we're handing in, as I said before, we want to hand in the interface, so the ABI, and the address of the contract. So this will be used to get the owner of the contract understanding where the contract is and what the methods on the contract are. The rest is not so relevant. So it won't be in the copy pasted code that you have copied from the workshop. Finally, the user card. We're using the Web3 library, so we're actually injecting the Web3 library. Let's go ahead and add those here. So we'll add user card. So when we call in the user card function, sorry, the user card component, here's the user card component. We're creating a standard function component, user card. We're exporting that out so that we can import that into our application. Then we are injecting the Web3 API as a parameter of the actual component. You can also see that we're injecting it as a parameter of the app itself. So you'll see in the index.js is where we've actually set it up. So we're calling the app component with the Web3 API and adding the Web3 API that we call in, which is our API here, from the index, so that anything below the app level can just use it as a parameter. And we'll go ahead and actually add the fun card as well. So that is it in terms of everything that we're going to be adding to the app.js. We're going to be creating the user card function, user card component, and the fun card component, and then adding them to the app. In the user card component, we're going to be setting or getting the network, getting the account, and getting the balance. So this is who we are. This is looking at our wallet. It uses the use effect, so it's an onload function to go and query our web API because it's all asynchronous. It's going to go, when it loads, go and query the Web3 API to get the network and get the wallet. It's getting wallet from our local provider. So it will actually be looking at your actual wallet and not looking anywhere else. And then it's going to set the state for the network, the account, and it will set the wallet balance based on what's in your wallet. And then we're using the way unit to, instead of showing ETH, because if you've got less than an ETH, then it will show up as 0. So we're dividing it by a way unit so that we can see a smaller unit. And that's it. So it's basically just providing that as some HTML so that we can display it on the screen, network, account, and balance. And the same thing for the fun card. We're doing querying the Web3 API to get the contract owner. This is where we hand in the ABI and the address. We're importing the contract from our contracts folder, which is just a JSON. So we're handing off the ABI JSON and the address from the contract. And then we're just awaiting any data that comes back from that so that we can set the contract owner. And actually, that should be balance. And then we're also getting the balance from, that should be that one. Sorry, we're setting balance of that guy. So set balance of the balance that we get returned from the query. And again, we have to divide it by the way unit. If you want to see what a way unit is, it's these guys here. So way is divided by a billion, I believe, or a million. That's way more than a million. 100 billion. and a Gwei unit is divided by this amount here. You can count the zeros later to understand how many zeros exactly that is. So that's how we divide to demonstrate that something that's less. It's a unit we use for less than a ETH on the Ethereum network. And then again, the same thing. We're just displaying the results in HTML, and so that's when we add them to our app, they're just displayed. And so if we go and run this now, so I did have this running locally. You can see I can see my details. I'm on the Go Early network. This is my wallet account, and this is my current balance in ETH. So that's why I've divided it, because it's less than 1 ETH. So this is showing up as point whatever, because it's divided by Wei. So it's 0.2 of an ETH. And then the fund. So this is the contract that I have deployed on the Go Early network. That's the contract address. And this is how much I've so far sent to that contract. So that's the current balance of the contract. I'm going to leave it there. I'll demonstrate. That's the wrong one. So that's the send funds. Sorry, we're not adding send funds for web. This one. This is the lab 2 running in the S3 bucket. So you can see the same details for lab 3. We're going to be doing the send funds section in lab 4, where we show how to do transactions through the API as well. So that's it for creating the application. The final part of the workshop will take you through when you run this for the first time. It will ask you to authenticate with your wallet, so allowing you to connect to your local wallet, because it's asking, as we looked at in the code, it's looking for the local provider. Doing this, when it prompts you to do that, you'll need to log into your wallet, and then you'll need it to be connected. So if it's not connected, it'll ask you to go through and connect it. You may need to manually connect to the site. Select manually connect, hit next, and then once it's connected, it will then actually be able to show you your account ID and balance. So it's pulling that from your wallet, or it's using the wallet address to pull that from the network. The rest I've been through, and so that's it in terms of setting up a Web3 application. The last bit is as simple as we want to sign back into the console, and then we're actually just going to, in the same way that we uploaded our Lambda into Lambda as a zip, we're going to upload the contents of the app that we created. So the entire, grab the wrong one again. We're going to upload the entire contents, or if you do a run build and just take everything from the build folder, you want to upload the contents of your build into the S3 bucket, and then that's it. Once it's uploaded, you will be able to access that on your distribution, the CloudFront distribution. Okay, so let me jump back to the diagram. And that's it. So essentially, we've created a single page application using React. We've created a Amazon managed blockchain node, which all but the last one is ready now. We've created a node, and we've created a Lambda to talk to that node. We've created an API gateway as a proxy to that Lambda. We've created some hosting, so our S3 bucket and our CloudFront distribution. We've then created a React app as a single page application. We're communicating with the Amazon API gateway to then send our requests through to the Lambda to the Amazon managed blockchain. And also from our browser, we're talking to our local wallet to get the address to do a query for our address, our wallet address on the blockchain. And then we're running it locally, or we're now hosting it in S3 buckets. So now we actually have a single page application as a decentralized application hosted on AWS, as well as using Amazon managed blockchain hosted on AWS to talk out to the Ethereum network. All right, I will leave it there. I hope you've enjoyed going through this presentation or through this workshop, and I'm sure there are plenty of questions for the Q&A takers next. Thank you very much.